Today we're going to be talking about parallel lines and proportional parts. There's a lot of important theorems and properties of parallel lines and proportions, and there's a lot of stuff in this section, for lack of better words. Okay, so triangle proportionality theorem. So if TU is parallel to QS, then I have some certain proportions. TR is going to be proportional to QT, as RU is proportional to US. So how I look at that, I have this piece there is to TU as RU is to US. And there's a whole lot of different proportions that I can now form out of this. So, example 1, looking at this diagram. MN is to NO, so MN is to NO as MJ is to JK. Next I have JK is to KL. So look at the corresponding pieces, or look at what's common, again, for lack of better words. JK is to KL as something is to OP. Look at what's common. I had these little blue segments here. I have this little red segment, so that's going to be an O. NJ is to OK. Actually, I want to do that in a different color. NJ is to OK. As MJ, this little side of that triangle, is to the whole thing MK. PL is to NJ. Where's NJ? NJ as something is to MN. Well, I have this side of the triangle and this segment, so now I'm looking at this big angle, MP. I'm sorry, but that big side. I'm sorry, not angle, side. Okay. Okay. Okay is to PL as MO is to this side here, MP. And lastly, we have MJ is to ML as something is to LP. Well, it's like, look at triangle MLP. So I have the long side, and then when I'm looking at triangle MJN, I have these short sides, so this should be NJ. So it's looking at the corresponding pieces and how can I fill in my proportion with the similar sides. Okay, if triangle RST is parallel, in triangle RST, RT is parallel to VU, SV is 3, VR is 8, UT is 12. I'm looking for SU. Okay, so if I have parallel lines, then my pieces are going to be proportional. So 8 is to 3 as 12 is to X. And this all comes, just so that you guys realize, this is all based off of similar triangles. I've just chosen not to give you guys, to prove those similar triangles with you. So 36 over 8, I reduced that fraction to 9/2. Okay, another example. AG. AG, where's AG? AG is right there. Okay, so AG, this is part A. AG is to GF as AB is to BC. And now fill in. AG is what I'm looking for. GF is 6. AB is 3. BC is 4. Nine halves. Okay, for part B, you know what? I will do B up here. I might run out of room and have to subtract. Okay, I'm looking for FC. Well, I know this piece, so I know FC is to GB as FC, so this whole segment, 7, so I'm going to write out the whole segment for you. AC, GB, that corresponding side would be AB. So FC is what I'm looking for. GB is 2. AC is 7. AB is 3. Okay, I'm gonna erase that little piece. Okay, ED. So I'm gonna look at that like ED, very similar to what B was. ED is to GB as the whole segment, AD is to the little piece, which is AB. ED is what I'm looking for. GB is 2. AD is 7, 8, 9, 10. AB is 3. X equals 20 over 3. And then lastly, part D. I did have room for everything. Okay, so part D. AE. Let me erase. Wish I had one more color. I'll use this gray. AE. AE, where's AE? So this whole segment, I'm trying to think of a fun. So AE is to use ED, which we found was 20 over 3. So the long side in the triangle, as AG, which we found was 9/2 over GB. So AE is what I'm looking for. ED is 20 over 3. AG, 9/2. GB is 2. So 2x equals, 9/2 times by 20 over 3. That can cancel 1 and a 10. That can cancel to be a 1 and a 3. So I really have 2x equals 30. X is equal to 15. Okay, the converse. So we know the converse of the if and then switch. If RT is proportional, RT over TU is proportional to RS over US, then I know that TU has to be parallel to QS. So next example, in triangle DEF, DH is 18, HE is 36, DG is half of GF. So, okay, so DG is half of GF. So let's look at that. So DH over HE is 18 over 36. So that's in a ratio of 1 to 2. DG is equal to 1/2 GF. If I divide both sides by GF, DG over GF is equal to 1 to 2. So my proportions are the same. So yes, by the converse of the triangle, what do we call it? Yeah, the triangle, I just wanted to make sure it was triangle proportionality theorem. Okay, triangle midsegment theorem. This is also a favorite of mine. If J and K are midpoints of FG, so if I have midpoints of two sides of a triangle, then the third side of the triangle is parallel to JK. JK is what we call the midsegment. It's the midsegment joins two midpoints of two sides of the triangle. And also, JK is half the length of FG. Said another way, twice JK is equal to FG. So, okay, there's two things. Triangle midsegment. So the midsegment. Joins the midpoints of two sides of a triangle. So I have two sides of a triangle. If I have a midsegment, that segment, JK is going to be parallel to FG. Also, JK is half the length of FG. Okay. In the figure, DE is a midsegment. So this is a midpoint. This is a midpoint. I'm going to mark that equals. So that's equal to that. That's equal to that. And EF is a midpoint. So, or midsegment. So those are equal. Find AB, FE, and angle AFE. Okay, so AB Okay, if DE is a midsegment, DE is equal to half AB. DE we know is 5. So therefore now AB equals 10. Now finding FE. Okay, FE. The whole segment, okay? Since FE is a midsegment, FE is half the third side of the triangle, so that's BC. FE, BC, they tell me is 18. FE is equal to 9. And then the last thing I need to find is angle AFE, this angle here. Okay, so I have this line, my midsegment, okay? I have AF and ED. We know that those lines are parallel because I have a midsegment. FE is a transversal, so 87 is going to equal AFE by alternate interior angles. So that equals 87 degrees. Okay. Next. If R is parallel to S and S is parallel to E, so all three of these lines are parallel. And we have some transversals that cut. We have UW over VX. UW is to, actually no, I want to change what I'm writing there. UW is to WY as VX is to XZ. So solving for X. They didn't tell me anything here. I'm going to assume, oh, they did tell me stuff. These angles are all equal. These are, remember, corresponding angles. So if those angles are equal, then I have parallel lines. So 3 is to 3.5 as X is to 9. So 27 is equal to 3.5x. X is equal to 54 over 7 is what I have here. Okay, next example, and I think this is, this is example 7. Okay, congruent parts of parallel lines. So if AE is parallel to BF, which is parallel to CG, and AB is congruent to BC, so if I have parallel lines and congruent parts, the other, whenever you have another transversal that hits those parallel lines, those segments, so EF is going to be congruent to FG. So solving for X and Y, I have here parallel lines, and I have congruent pieces. So I know 3x minus 7 is going to equal x plus 5. So I have 2x equals 12. x is going to equal 6. Since I have congruent pieces and parallel lines, I know 9y minus 2 is equal to 6y plus 4. Subtracting the 6y over, 3y, adding the 2 over, 6, y is going to equal 2. Okay, I realize that was an empty video. That is a lot happening. Okay, please, thank you for watching my video, I should say.